Okay, so this is going to be the video for combination and decomposition reactions. Um, the main thing to go through is just being able to identify them. I'm going to work through some examples for you just to kind of show you what they did in the notes, but the main thing for you guys is just to be able to pick them out. So combination reactions are also called synthesis reactions because we're going to make something. So we're taking two reactants and making one product out of them. So here's just some very basic ones to go through. So if I have magnesium and I combine it with oxygen, so if I burn magnesium using oxygen gas, I'm going to put these two things together and make MgO. Well, the way to figure out the formula that I make is I have to know the charges. Magnesium by itself is a 2 plus and oxygen is a 2 minus. So when they go together, I'm going to form the compound of MgO. Now you'll notice that's not balanced because I have two oxygens on this side and one on this side. So I balance it by putting twos in front of those things. I have to make what formula would form. I can't just write MgO2 to make them balance. I have to write the correct formula first. So like sodium and chlorine going together. Sodium is a 1 plus, chlorine is a 1 minus. So I'm going to make NaCl, but that's not balanced. So I balance it by putting twos in front of those. Another thing, it doesn't have to be elements that combine together. It can be two compounds that combine together. A metal oxide like calcium oxide, when it reacts with water, is going to form a metal hydroxide. So I'm going to take my metal and it's going to join up with hydroxide. So calcium, and it's a 2 plus. And I know that hydroxide is OH and it's a 1 minus. So when I put those together, I form Ca parenthesis OH2. And then that ends up being balanced. Your main thing that you guys need to be able to do is just to identify that, hey, those are synthesis reactions. And also don't forget these diatomic molecules. Notice how I write things like oxygen as O2 and chlorine as Cl2. So I have H2, N2, O2, F2, Cl2, those 7 diatomic molecules. So a decomposition reaction is the opposite. Decomposition just means things are going to decompose. They're going to break apart. So I have one reactant that's going to decompose into multiple products. So here I'm starting with one reactant of silver oxide. Well, that is going to decompose into silver metal and oxygen gas. I have oxygen by itself, so it has to be O2. Well, now that's not balanced. So I have to put a 2 in front of this, and then that means a 4 in front of that, and it balances. Calcium carbonate will decompose. Carbonates will decompose into very specific things. Carbonates specifically will decompose into carbon dioxide gas and a metal oxide. So my metal bonded to an oxygen. So my metal in this case is a calcium, which is a 2 plus, and oxygen, which is a 2 minus, so CaO. And that ends up being balanced. It won't always work out that way, but calcium carbonate will always decompose into carbon dioxide gas and calcium oxide. How we know it's carbon dioxide gas, if I took like a burning splint, which you guys would have done if you would have done the labs for this, if you take a burning splint and you put it inside the test tube where carbon dioxide gas is, it'll extinguish the flame. Carbon dioxide will not support combustion. A metal chlorate, so if I have something that's a metal bonded to chlorates, like in this case, potassium chlorate, they are going to decompose into a metal chloride. So the metal, which is potassium, is going to combine with chlorine. So that's a 1 plus 1 minus. Plus oxygen gas is going to be given off. Well, this isn't balanced. I have 3 oxygens here and 2 here. So I need to put a 3 here, a 2 here, and a 2 there. And now my whole equation's balanced. But the point is I start with one reactant and I get multiple products out of it. And this one would support combustion. So if I put a burning splint in there, it's going to continue burning or the flame's going to get bigger because oxygen gas is being released. So that's kind of the basics on what a synthesis reaction is, making something, and a decomposition reaction is breaking something down.